Already we have discussed in the yesterday class. What are the some concepts of in the previous class? What are the discussion of in the previous class? Now that is the straight line and some of the types of straight line weavings. Okay. Now, what are the types of straight line formations? Symmetrical form and non-symmetrical form or unsymmetrical form. How to conversion the symmetrical to non-symmetrical and non-symmetrical to symmetrical. And at the same time, what is the point of intersection? What are the coplanarity lines? Now already we have discussed in the previous class. Some other problems are also here. Okay, please stay on the line. Screen share here. Just you have to see here. Please here. The continuing of the next class, previous class. Okay. Now, please here. This is one of the important expression here. Already transformation from unsymmetrical to the symmetrical form. Now, already we have discussed this problem. Find the symmetrical form of the equations of the line. Already in the previous class discussed especially this problem. Now, according to this one, please stay on the line. Now, this problem is also discussed here. Find the equations of the line through the point 1, 2, 3. This is one of the point. This point is parallel to the line. Okay. Next one, and I have practiced some other problems. Angle between the line and a plane. Now here the formula is sin theta equal to plus or minus L plus Bm plus Cn by root of sigma A square into root of sigma L square. Okay. Now this problem is also angle between the line. This problem is also discussed 4.3.2, and at the same time point of intersection of the line with the plane. This problem is also practiced here. Okay. Conditions for a line to lie in a plane. Already this is also discussed. Here the condition is L plus Bm plus Cn equal to 0. And according to the theoretical expression, and here the coplanarity lines and the condition for the coplanarity of lines. Okay. Just you have to see here. See in your textbook. Okay. Page number, please see that page number 111, 112, 4.6.1. This problem is also very important in the final examination. Okay, what is that problem? Show that the lines x plus 3 by 2 equal to y plus 5 by 3 equal to z minus 7 by minus 3. This is one of the symmetrical line. And second one is x plus 1 by 4 equal to y plus 1 by 5 equal to z plus 1 by minus 1. Okay, there are two lines here. Just you have to see and observe. First of all, we must observing the given the data. Here there are two symmetrical lines is given. Now here the first symmetrical line on the point is minus 3, because x plus 3 can also be written as x minus of minus 3. Y plus 5 can also be written as in the first symmetrical line y minus of minus 5. So that's why first symmetrical line on the point is minus 3, minus 5, 7. Okay, first line normals are 2, 3, minus 3. And at the same time, we are observing given the second symmetrical line on the point is minus 1, minus 1, minus 1. Because that line can be arranged in the symmetrical form x minus x2, y minus y2, z minus z2, x minus x2 by l2, y minus y2 by m2 equal to z minus z2 by n2. So here x2, y2, z2 is minus 1, minus 1, minus 1. So that's why both lines are coplanar here. Coplanar, what about the condition of coplanar? Here the modulus, just you have to see the solution. First of all, we are observing given the data. Here, according to that condition of coplanarity, modulus x2 minus x1, y2 minus y1, z2 minus z1, or x1 minus x2, y1 minus y2, z1 minus z2, L1, M1, N1, L2, M2, N2. Now, here, first line of the point is minus 3, minus 5, 7. So, according to that, second line of the point is minus 1, minus 1, minus 1. So, that is x1 minus x2 means minus 3 minus of minus 1. So, minus of minus 1 is plus 1. Minus 5, minus of minus 1. 7, minus of minus 1. So, that's why L1, M1 is the first line of the normals 2, 3, minus 3. Second symmetric line of the normals 4, 5, minus 1. And to find the determinant of this part, we are getting that value is 0. Okay. Now, here the equation of the plane containing the two given lines. Okay. Now, what about the equation? X minus x1 modulus. Now here according to the theory, okay, according to the theory, what about the condition of condition? Modulus x minus x1, y minus y1, z minus z1, L1, M1, N1, L2, M2, N2 equal to 0. Now again we have to find this is the plane containing the plane equation. Okay, the equation of the plane containing the two given lines, first equation and second equation, either through first equation or second equation, and according to the normals, we are getting the value here modulus x plus 3, y plus 5, z minus 7. To write the normals in the first line 2, 3, minus 3, second line of the normals 4, 5, minus 1. Again, the determinant equal to 0, equating to 0. We are getting the first line of the equation from the first line of the containing of the plane equation. So modulus x plus 3 of AD minus BC, and the first column must be absent, and the remaining the part is that is minus 3 minus of minus 3 into 5, that is plus 15, minus of y plus 5 into that is what about that, and minus of here we are getting the minus of y plus 5, that is 10 minus 12 is there. Okay, so minus 2 plus 12 is there, plus z minus 7 into 10 minus 12 equal to 0. Now we are getting the equation is 6x minus 5y minus z equal to 0. Just you have to clean observe it is the first plane is passing through the origin, because there is no constant given that equation. 6x minus 5y minus z equal to 0. Now this is the containing at the origin. So the plane which same in the we are getting the another one mod x minus x2, z y minus y2, z minus z2, L2, M2, N2, and L1, M1, N1, L2, M2, N2 equal to 0. We are getting the another equation. So here getting the a plane which containing the line first equation and it is parallel to the line second equation. Okay. Now it is also similar. Show that the lines are intersect. Now there are two symmetric lines is given. Find the coordinates of the point of intersection and the equation of the plane containing them. That is also in the same manner. Already we have practiced in the above problem. Okay. Line intersecting two given lines. Already this problem is also discussed in the previous class. Okay. Find the equations line. This problem is very important in the final examination. Now there are two non-symmetrical lines or unsymmetrical lines. Now here, first just we are observing, we must observing the given the non-symmetrical lines 2x plus y minus 1 plus lambda 1 of x minus 2y plus 3z, and in the same manner 3x minus y plus z plus 2 plus lambda 2 of 4x plus 5y minus 2z minus 3. Okay, now there are two equations here. Suppose we are intersecting of the plane equations is first plane plus lambda p2 into, and here given the lambda s1 plus lambda s2 equal to 0, and according to that intersecting of the planes, now we are writing the given the non-symmetrical part in terms of lambda 1, and that is the lambda 1 is a scalar, and at the same time we must writing in the second non-symmetrical part from lambda to scalar part. Okay, now here the xyz is common in both. We are required, so the entire this part is parallel to the given the line is what about the line? So x by 1, y by 2, z by 3. Now this is the point is given the line 0, 0, 0 is there because there is no point. So directly we are substituting the normals LMN 1, 2, 3 in the replacing of x, y, z is there. We are getting the lambda value and the lambda 1 value on both equations from writing this one. Okay. Substituting this part and again substituting this part. In the replacing of x, y, z values are 1, 2, 3 from the given the line. Okay. Now it is parallel. We are getting the lambda and the lambda 1 values. Those values are substituting in the above equation. We are getting the required non-symmetrical part as an individual part. Okay. 4x plus 7y minus 6z minus 3 equal to 0 from the lambda value substituting, and another one when the lambda 1 value substituting, we are getting the 2x minus 7y plus 4z plus 7 equal to 0. This is the non-symmetrical expression. Okay. At the same time, this is also practice purpose. Okay, 4.8.1. This is the distance. Okay, find the distance of the point -1, -5, -10 from the point of intersection of the line. Okay, now the given the line and the plane is given, line is given, find the distance of the part. Already we have discussed in the previous class. Last class is there. This problem is important, and also I have to repeat here. Given line must be an equating to small r. Now here the coordinates of the point is 2r plus 2. This is 2r plus 2, and this value is an equivalent to r, 4r plus 4r minus 1, 12r plus 2. That is the x, y, z coordinates here. Now this is the, now it read as the coordinates of the point on the given the line. Okay, when if it lies given the plane, the plane normals are 1, -1, 1. Okay, now that values are substituting in the above expression. Now this value, x value is substituting given the plane, y value substituting given the plane, and at the same time x, y, z expression. So the point is substituting in the given the plane, then we are getting the r value is there. So when the r value substituting in the above point, this is the point, r value is 0. When the r equal to 0, 2 minus 1, 2 is there. Okay, now that is one of the point. Already this point, required point of intersection is there. So the given line meets the given plane and the point is 2 minus 1, 2 is there. Already one point is given, P point is given, and Q point is also, we are required the point. Okay, we have found the value. So one point is minus 5, minus 5, minus 10, and another one is 2, minus 1, 2. There are 2 points. In between any 2 points of the distance is PQ equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. And according to that, we are getting the value is 13. Okay. Now that is the distance of the problem from the line and given the plane. Now, in the same manner, 4.8.2, this problem is also practiced here. Okay. And 4.8.3, this is also one of the important, find the equation of the plane. First of all, see here, getting the plane equation is there. So, suppose that plane passing through the point 1, 1, 1, this is the 4.8.3 problem. See and referred here. And it is also perpendicular to the line. Okay, line is given. So first of all, write the given the line non-symmetrical form, and here that line also intersects. Just you have to write the xyz coefficients to write the normals in terms of ABC. So a minus 2b plus c equal to 0, 4a plus 3b minus c equal to 0. Okay, by CMR cross multiplication rule, we are getting the values minus 1, 5, 11 is there. So finally, the equation of any plane perpendicular to the given line is, so what is the given line? Minus x plus 5y, ABC value substituting in the normal plane equation, minus and ax plus by plus cz plus d equal to 0. That's why minus x plus 5y plus 11z plus d equal to 0. Okay. Now this plane is passing through the point 1, 1, 1 is there. So replacing of the x coordinate, y coordinate and z coordinate. So that value substituting here the required plane equation, we are getting the d value. So finally the required plane is minus x plus 5y plus 11z minus 15 equal to 0. Finally, we are getting the plane equation is x minus, because according to the given the data, every problem from the theory now easy to solved. Okay. Now x minus 5y minus 11z plus 15 equal to 0. Okay. Now this is also one of the projection problem. Find the length of the projection of the line joining points. There are 2 points is given, minus 1, 2, 0 and 1, minus 1, 2 on the plane 2x minus y minus 2z equal to 4. So A point, B point is here. Find the distance from the given the points, line joining points, AB equal to root of x2 minus x1 whole square. According to that formula, we are getting the value is root 17. This is the root 17. And again, the drs of the line AB are, what are the drs? X2 minus x1, y2 minus y1, z2 minus z1. So that is 2 minus 3, 2. So the drs of the normal to the plane is 2 minus 1 minus 2. And theta is the angle between the line AB given the plane is pi by 2 minus theta. So according to that, one line is given and the normals are also there. And sin theta equal to plus or minus AL means 2. AL means 2 minus 1. Minus 2 is there. That is the drs. And here the 2 minus 3. What about that? 2 minus 1 minus 2 is here. Okay. And again, the drs of the line AB are 2 minus 3, 2. And both are substituting in the values of A, B, C and LMN is there. So 2 into 2 plus minus 3 into minus 1 plus 2 into minus 2 is there. By square root of 2 square minus 3 whole square plus 2 square into square root of 2 square plus minus 1 whole square plus minus 2 whole square. After the substitution, we are getting the 1 by root 17. So already we are getting the value sin theta. Suppose we have to find the value of cos theta, that is square root of 1 minus sin square theta, that is 1 minus, say this is 1 minus sin theta means 1 by root 17 whole square. Square means that is the whole square, or cancel the root is there. After simplification, we are getting the value is 16 by 17. Root 16 means 4 by root 17 is there. Okay. This is the simplest expression. So AB cos theta, the length of the projection of the line AB on the given the plane is, that is the projection of the formula AB into cos theta. So AB value is root 17 and cos theta is 4 by root 17. So finally we are getting the value is length of the projection is 4. Okay. That is the simple expression. Okay, 4.8.5, this problem is very important. So line is given and that line is perpendicular to the plane x plus 2y plus z equal to 12. So find the equation of the plane. So according to the given the line, okay, a of x minus 1, a, b, c be the normals, and according to that, a of x minus 1 plus b of y plus 1 plus c of z minus 3 equal to 0. So already one of the formula is a of x minus x1 plus b of y minus y1. Already here x minus x1 means x minus 1, y minus y1 means y plus 1, z minus z1 means z minus 3. So point is given and the plane equation is a of x minus x1 plus b of y minus y1 plus c of z minus z1 equal to 0. After the simplification where here 2a plus from the normals. What are the normals? Given the line 2 minus 1, 4. These expressions is also in terms of ABC 2a minus b plus 4c equal to 0. So second equation is perpendicular to the given plane. So x plus 2y plus z minus 2l equal to 0. Here the normals are given the plane 1, 2, 1 is there. So that's why those values are also writing in terms of ABC a plus 2b plus c equal to 0. Okay, this is also expression. See here. From third and fourth equation, a value is, so by CMR, by entire, the concept is also surrounding in the part of CMR. From cross multiplication rule, that is ABC. ABC equal to minus 925 is there. Though those values are substituting in second equation, we are getting the plane equation is 9x minus 2y minus 5z plus 4 equal to 0. Okay, so that's enough. Okay, now this problem is 4.8.6. Already you have discussed in the previous class. First 2 points, we are getting the line joining of the formula. Now C and D, third and fourth points, we are saying that C and D is there. That is our assumption. C and D points substituting in this part of the completion here, replacing XYZ by C point and one time, and next time another one. D point is also substituting in the first equation. So enter all the values are satisfying here, C and D points. So given the points are collinear. Okay, 4 points lie on the same straight line. Okay, this problem, find the image of the line. This problem is also I have discussed here. Okay, 4.8.7, very, very important in the final examination. Don't forget this one. Okay, this problem is very important already. Here, according to the point and line, we have to find the image, but here the line and the plane is given. Find the image of the line. So line of the image, we must found the value of image of the line. So here the point is 1, 0, minus 2. You are given of the coordinates of any point on the line. So, but here especially point is on the line is x1, y1, z1 is 1. Here there is no y1. So that's why 0. 1, 0, minus of minus 2 means minus 2. So 1, 0, minus 2 is the point on the given the line. To be the image of the point in the given the plane. So that's why just you have to write the x minus 1 by 2 equal to y by 1 equal to, according to the normals, 2, 1, minus 3. 2, 1, minus 3 from the normals of plane. Okay. So write the x minus 1 by 2 equal to y by 1 equal to z plus 2 by minus 3. Say that is the small r. Here the coordinates of the point on the line is 2r plus 1 r minus 3r minus 2. So the midpoint of PQ. Okay. Already point is here. From the line 1, 0, minus 2, that's the point is say capital P. Here the coordinates of the point is capital Q. So from the P and the Q, find the midpoint. Midpoint of the formula x1 plus x2 by 2. So given the point on the line, point is x1, y1, z1. Q point is x2, y2, z2 is there. And what is the midpoint of the formula? x1 plus x2 by 2, y1 plus y2 by 2, z1 plus z2 by 2. We are getting the value. So that value substituting in the plane equation. So that value is R value is minus 4 by 7. So R value substituting in the capital R. Now we are getting the image of the point. Okay, so any point on the given the line is S of, okay, 2r plus 1 minus r, 2r minus 2. Okay, 2r, that is the S point, say, okay, 2r plus 1. And what about that? That is the Q point. S of 2r plus 1. Any point on the given the line is S of 2r plus 1 minus r, 2r minus 2. So that point is also substituting given the plane. So r value is there. So another point is capital S equal to 11 by 3 minus 4 by 7, 2 by 3. So the direction ratios of the line QSR. Okay. Now that is 20 minus 4, 5. So equations of the image of the line QSR, x minus x1. x1, y1, z1 are minus 1 by 7, minus 4 by 7, minus 2 by 7. So already we have to find the value of q is there. So according to that, this is x1, y1, z1, and L2, M2, N2 are 20 minus 4, 5. That is the LMN values. Write the line equation. So that's why x plus 1 by 7 by 20 equal to y plus 4 by 7 by minus 4 equal to z plus 2 by 7 equal to 5. This is also one of the important problem. 4.8.8. See and practice this problem, because each and every problem is on the same manner, and both are non-symmetrical lines. So given the lines are coplanar, find the equation of the plane in which they lie. So this is also in the same manner. There is no problem. Okay, you have to practice here. Okay, this is the end of this part. Okay, that is the 4th unit is there. Already 4 units. Now, irrespective of the each and every concept we have discussed. Okay, now according to this theory, and to practice some other problems on the continuing of this part. Maximum in this first 6 classes, these 6 online classes, we have discussed half of this part is also completed now thoroughly. Okay. Next one, skew lines and the shortest line segment between 2 skew lines. Okay, this is also one of the important, how to find the shortest distance from the given the skew lines. So what is the skew line? Any 2 non-coplanar lines which do not intersect. Any 2 non-coplanar lines which do not intersect. Okay, when the given the lines are non-coplanar, when the does not intersect is there, those lines are called skew lines. Okay, that is the definition of the skew lines. One of the important bit is there. And at the same time, here according to this theory, how to find the shortest distance in between the 2 symmetrical lines and in between the non-symmetrical lines, in between the line symmetric and non-symmetric of this part. Okay. Length and equations of the shortest line segment is there. Now this is the theory. Now given lines are, there are 2 lines is given, x minus x1 by L1 equal to y minus y1 by M1 equal to z minus z1 by N1. So how to discuss the length or magnitude, whatever it is, that is the shortest distance. X minus x1 by L1 equal to y minus y1 by M1 equal to z minus z1 by N1. That is the first symmetric line. Second symmetric line is x minus x2 by L2 and y minus y2 by M2 equal to z minus z2 by N2. Here the first line of the point is say capital A. Second line of the point is say capital C is there. LMN be the DCs of the shortest line segment. Okay. So GH is perpendicular to both AB and CD. That is LL1 plus MM1 plus NN1 equal to 0. And second one LL2 plus MM2 plus NN2 equal to 0. We are getting the values of LMN. So that value is an equivalent to 1 by sine theta. So that is the theta is the angle between the line AB and CD. Just you have to observe given this figure. Okay. AB. So this is the one of these 2 lines are non-symmetrical because non-coplanar of this part. Okay, non-symmetrical means first of all, you are taking the AB, in between the point is capital G, so G is perpendicular to H, so GH is perpendicular to CD. So that's why AB and CD, there are two non-coplanar lines here. So GH is perpendicular to both AB and CD is here. So we are getting the value is line, therefore length of the shortest line segment. So according to the concept, this formula is also shortest distance equal to B1 bar. Now that is the vector representation we are also taken. That is one of the type, and a box of B1 bar, B2 bar of A2 bar minus A1 bar by modulus B1 bar cross B2 bar. This is one of the direct, we have to find the lines length of the shortest distance. Okay, from this through the vector notation. But here, according to this one, okay, now how to find the equation? Mod x minus x1, y minus y1, z minus z1, and L1, M1, N1 is the first line of the normals. LMN be the common intersecting of the lines. Normal, from the normals of the both lines, we are getting the values of LMN. So that is the one of the required plane equation. And according to the second symmetrical line, we are taking the det of mod x minus x2, y minus y2, z minus z2, L2, M2, N2, and LMN equal to 0. Now, just you have to see and practice the problem. 5.2.2. Now, without this problem, we can't expect the final examination. Find the length and the equations of the shortest line segment between the lines. Now here the one of the symmetrical line is, this is the symmetrical form, x1, y1 is minus of minus 9, z1 is 10. So x1 is 8 minus 9, 10. This is the any point on the line, given the line 8 minus 9, 10 is there, and first symmetric of the normals 3 minus 16, 7. And second symmetrical line is x minus 15, y minus 29, z minus 5. Normals is 3, 8 minus 5. Okay, that is the, there are two methods. First of all, so you have to see the first method is there. Given the DRs, writing the DRs, DCs, LMN be the DCs of the line shortest segment between first equation and second equation. Okay, now first line of the normals, 3 minus 16, 7. Just you have to, we are taking those normals in terms of LMN is there. 3L minus 16M plus 7N equal to 0. Second line of the normals, 3, 8 minus 5. Now those normals are also writing in terms of LMN. So that's why 3L plus 8M minus 5N equal to 0. Now after the CMR expression means cross multiplication rule on both. So suppose we are getting the value of L. This is minus 16 into minus 5 minus 7 into 8. So minus 16 into minus 5 means that is how to 80 minus 56. Okay, we are getting the 80 minus 56 means that the value is 20. L value. Suppose M value is, we are taking the reverse part, 7 into 3, 21 minus of minus. So plus 15. So 21 plus 15, we are getting the value is 36. And N value is there. We are getting the N value from the coefficients of L and M on both. 3 into 8, 24. Minus of minus plus 16 into 3, 48. So 24 plus 48, we are getting the value is, okay, values, N value is here. So LMN values are cancelling by 12 or 6, 2 12s are 24. Now this is the, some mistake is here. N value is 3 8s are 24 plus 48. 24 plus 48. 72. Okay, this is 72, not 12. Please rectify this one. This value is 72, not 12. Students, listen carefully. Okay, here the mistake is there. So after the cancelling by 12, 2 12s are 24, 3 12s are 36, 6 12s are 72. This is not 12, 72 is there. So the DRs of the shortest line segment are 2, 3, 6. So therefore the DCs of the shortest line segment, L value is, what is the L value? So after the completion of, this is the normals, and the DCs means square root of 2 square plus 3 square. So 4 plus 9, 13, 13 plus 36, 49. So root 49 means 7. So L value is DCs are 2 by 7, 3 by 7, 6 by 7. Okay, that is the square root of 2 square, 3 square, 6 square. Okay, now a point on the line, first equation is, what is the point? 8 minus 10. 8 minus 9, 10 is the first line of the point. Second line of the point is, what is that? Second line of the point, x2, y2, z2, 15, 29, 5. So those points on the from the shortest line segment, and hence here L value, L of x2 minus x1, 15 minus 8, plus M of y2 minus y1. Simple expression, plus M of y2 minus y1 is here. 29 plus 9 plus N of N value. What about the N value? 6 by 7 into Z2 minus Z1. So that was Z2 minus Z1 means 5 minus 10. So we are getting the value is 14. So that is the shortest line segment of the distance. So here the equation is so simply concept L of x2 minus x1 plus M of y2 minus y1 plus N of z2 minus z1. After the simplification, we are getting the shortest distance or length or magnitude, whatever it is. Okay, or distance. Now again, find the equations of the given the symmetrical, from the symmetrical part. How to find the plane equation? Mod x minus x1, y minus y1, z minus z1. From the first symmetrical part, to write the components x minus 8, y plus 9, z minus 10, L1, M1, N1, LMN values. Already you have to find the LMN values 2, 3, 6 in the above expression. So the equal to 0, we are getting the value is 117x plus 4y minus 41z minus 490 equal to 0. In the same manner, the second line of the second symmetrical part of the plane equation, mod x minus x2, y minus y2, z minus z2, L2, M2, N2, LMN values are 2, 3, 6. That is the common line intersection of the normals. So finally, we are getting 9x minus 4y minus z minus 14 equal to 0. So we are getting the values. There are two plane equations to write the to write the continuation of the part. We are getting the non-symmetrical form. This is the second method. Okay, just you have to see and observe according to the symmetrical method to find the points P point, Q point. Those according to those points we are getting the R and R dash values. So those values are substituting. There are 2 points is given. So length of the distance, their shortest line segment is PP dash equal to square root of x2 minus x1 whole square. And according to that value is also 14 is there. Okay, there is no problem. This is the second method. So equations of the shortest line segment are already we know that we have practiced in the above part. Okay, there is no. This is the third method. Okay, there are two skew lines. AB is one of the skew lines. CD is also another skew line. So first plane is pi 1 in between AB. Second plane is given in between C and D is there. So first plane is contains AB. Second plane it is parallel to the CD. Okay. Now that value, that expression is mod x minus x1, y minus y1, z minus z1, L1, M1, N1, L2, M2, N2 equal to 0. We are getting the plane equation. So perpendicular from the plane equation, perpendicular distance means that is modulus 2x plus, so ax1 plus by1 plus cz1 plus d1 by root of a square, 2 square, 3 square, 6 square. So ABC values are 15. Okay. Now from the plane equation, 15, 29, 5 is there. So now those values are substituting given the distance. There are 3 models to find the shortest line segment. Plane equations is also in the same manner. So that is the both are symmetric lines. Now suppose given the both lines are non-symmetric part. See the 5.2.3 problem. Find the length and equations of the shortest line segment between the lines x minus y plus z equal to 0. Okay, there are two lines is given, non-symmetric lines. First, transform the given the equations of the lines in the symmetrical form. Equations of two given lines in symmetrical form are x minus y plus z equal to 0. That is x by 1, y by 2, and z by 1. Equations of the two given lines in symmetrical form. So, first line is first plane plus lambda into second plane equal to 0, and second non-symmetrical line is also 2x plus y plus 2z minus 3 equal to 0. First, just you have to observe the first non-symmetrical part. There is no constant on first non-symmetrical part. So, first line is passing through the origin. So that those lines are equations to given lines in symmetrical form. X by 1 equal to y by 2 equal to z by 1. That is the first equation. And second one is x minus 5 by minus 3 equal to y plus 2 by 1 equal to z by 1 is there. So that is the common part. Okay. Already we know that from the non-symmetrical part, how to convert the symmetrical expression. Okay, now those lines are in terms of LMN, L plus 2m plus n equal to 0 from the first equation, minus 3L plus m plus n equal to 0, that is the third and fourth equations. So both values are solving, we are getting the LMN value 1 minus 4, 7. So the direction ratios of the shortest line segment, 1 minus 4, 7. So according to those values, L value equal to L equal to 1 by root of 1 square plus minus 4 square plus 7 square. So 1 plus 16, 17, 17 plus 49, root 66. So m value is minus 4 by root 6, n value is 7 by root 66. So now we a point on the line, first equation is origin, second line of the point is 5 minus 2, 0 is there. So the projection of the joining the points, first line point is origin, second line point is 5 minus 2, 0. So L of x2 minus x1 plus m of y2 minus y1 plus n of z2 minus z1, we are getting the distance 13 by root 66. Now the first plane containing the origin, so that's why we are taking the given the line mod x, L1, M1, N1, L2, M2 into N2 equal to 0. So here LMN values are common intersection. Point of common intersection are 1 minus 4, 7. So we are taking the values of LMN for the equation. So we are getting the values 3x minus y minus plus z equal to 0. In the same time, mod x minus x2, y minus y2, z2. So from the second line of the normals L2, M2, N2, LMN. Okay, we are getting value is there. So those plane equations combined, so that is the shortest line segment of the distance and their equations. Okay, 5.3, the length of the perpendicular from a point to a line. Okay, here x1, y1, z1 will be a point on the line, given the line, alpha, beta, gamma is the common point, say that is capital P is there, just you have to see and observe. So AB is one of the line and perpendicular of the part on the base. So P is perpendicular to Q. So PQ. PQ dash equal to, from the Pythagoras concept, to write as the AP square equal to x1 minus alpha whole square, y minus beta whole square plus z1 minus gamma whole square. So we are getting the value of PQ square equal to L of, what is that? After the simplification, we are getting the x1 minus alpha whole square plus y1 minus beta whole square plus z1 minus gamma whole square minus of L of x1 minus alpha plus m of y minus beta plus n of z1 minus gamma whole square. Okay, that is the expression. So 5.4.1, this problem is also important. Find the length of the perpendicular from the point 1, 2, 3 to the line, symmetrical part. Okay. This is also, there are methods from the Pythagoras concept to write from the above figure A, B. So A point is 6, 7, 7. So that is the symmetrical line of the given the point is 6, 7, 7. And common point is capital P is 1, 2, 3. We are taking. And another one, that image of the point P image is Q. So we are construct the, just we have to construct the figure that is the right angled that is the right angle triangle. So we are getting the APQ or AQP, whatever it is. So from the Pythagoras concept, so side square PQ square equal to what about that? AP square minus AQ square. So according to this one, AP square equal to, so PQ square means 1 minus 6 whole square plus 2 minus 7 whole square plus 3 minus 7 whole square. We are getting the value is 66. So the direction ratios of the given line 3, 2, minus 2. So line of the normals are 3, 2, minus 2. And hence the DCs of the line 3 by root of 9 plus 4 plus 4. So that is 13 plus root 17. 2 by root 17 minus 2 by root 17. So AQ equal to projection of AP and the given the line. So that is 3 by root 7 into, there are 2 points is given, A point and P point. Then their distance is 6 minus 1. M of 2 by root 7 into 7 minus 2 plus minus 2 by root 7 into L of x2 minus x1 plus M of y2 minus y1 plus N of z2 minus z1. We are getting the distance is there. Okay. So that value is 7. That is the required perpendicular distance. This is the second method. Just you have to see and practice this one. And this is also, there are three methods here. Just any single method to, you must present in the final examination only. Single method is also possible. There is no problem. And according to this one, intersection of three planes. Now this is one of the important character. Okay. Please join the line. Please. Now, just we are taking any three planes. What is the concept of intersection of three planes? Suppose any three planes, no two of which are parallel. So the given planes, any two which are parallel, no two of which are parallel, intersect is one of the following ways. Suppose first line, this problem is also very important. That is the regular problem. The shortest distance is the main problem. That is the given the SI problem is there. The planes may have a common line of intersection. A1x plus B1y plus C1z plus D1 equal to 0. Second one, A2x, B2y, C2z plus D2 equal to 0. A3x plus B3y plus C3z plus D3 equal to 0. There are three planes is given. The planes may have a common line of intersection of first one. Second result is the planes may form a triangular prism. That is, if the line of intersection of two of them is parallel, and third but does not lie on it. Okay. And the third condition is the plane may meet in a unique point. Okay. The plane may meet in a unique point. A very simple problem and very too interesting problem is there. If that is the meaning of unique point means if the line of intersection of two of them is not parallel to the third one. Okay. So these three results explain, that is also theory question is given. Explain the what about the condition of intersection of three planes? You must present the first condition, second condition, and third condition. The planes may have a common line of intersection. Second one, the planes may form a triangular prism. Third one, the plane may meet a unique point. There are three possibilities here. Just you have to, how to see the, given the theory. Just you have to see the first equation, second equation, and third equation. Okay. To write as the, from the first and second equation, both are intersect. To find the values of x1, y1, z1, because suppose z1 equal to 0. Okay. Now we are getting the b1, d1, a1, b1, b2, d2, a2, b2. So just you have to find the x1, y1, z1 point. Here the z1 point is 0. We are getting the values of LMN is there. And x1, y1, z1 or xyz point is here b1, d2 minus b2, d1 by a1, b2 minus a2, b1. Okay. So y minus of a2, d1 minus a1, d2 by a1, b2 minus a2, b1. So LMN values are, to write the a1L plus b1M plus C1N equal to 0, A2L plus B2M plus C2N equal to 0. We are finding the values of LMN by CMR. we are getting the L1, M1, and LMN is B1, C2 minus B2, C1, and M value is A2, C1 minus A1, C2, and N value is A1, B2 minus A2, B1. The line will be parallel to the plane, third equation. So to find the delta of the line, the line will be parallel to the line, third equation, if A1 of, okay, that is A1 of B1 C2 LMN A1L plus A3 of, because third plane equation is A3 B3 C3 normals, A3L plus B3M plus C3N. Here LMN values are in the denominator, so that's why I enter that value is equivalent to 0. So yeah, already just may be written as, given the determinant of this part, this equation can be determinant of this part delta equal to det of A1 B1 C1, A2 B2 C2, A3 B3 C3. So enter that det must be equating to 0. So after the determinant of this part, we are getting the required condition. See this one, either this or this. Now we enter this determinant part is delta. There are two cases arise. Okay, the line fourth equation lie wholly in the plane third equation. Okay, now how to get the fourth equation lies wholly in the plane third equation. So that is the common intersection part. Okay, the line fourth equation does not intersect the plane. So this is the prism part. Just you have to see and observe this is the prism. This is the prism part. This is the common line or unique point. Okay. No, line of the given the point is already, we have to find the line point is there. So that value can also be written as delta 3 equal to A1, B1. So that's why Z coordinate is 0. We are taking the coefficients X, Y and constant. A1, B1, D1, A2, B2, D2, A3, B3, D3. We are getting the condition is here after the determinant. So enter the determinant is 0. Okay, now the common line of first equation and second equation intersects either YZ or ZX plane. Okay, now if the intersection of the condition of common line of intersection of the three planes, either delta 1 equal to 0 or delta 2 equal to 0 or delta 3 equal to 0 together with delta equal to 0. So the common line first equation and second equation does not intersect third equation. Okay, so these three are delta 1, delta 2, delta 3 must be vanishes. Okay, now this is the problem, just you have to see and observe. Okay, there are four determinants here, delta 1, delta 2, delta 3. They form a first condition is the first of all, the given the planes, is it intersect or not? Okay, see the first problem. This problem is very important. Examine this is the nature of intersection of the planes. So examine the nature of the intersection of the following sets of planes. First problem, there are three planes is given. To just have to observe these three planes are different. No one is parallel to another two. So delta equal to, write the coefficients of from the first problem, 4 minus 5 minus 2, 5 minus 4 2, and 2 2 minus 2 to 8. So to find the determinant is an equivalent to 0. And again delta 1. To write the delta 1 constants, just you have to you are taking the coefficients from y and z, minus 5 minus 2 minus 2 minus 4 2 2 2 8 minus 1 without x coefficient. To find the delta 1. It is also delta 2 means without y coefficient, write the coefficients of x, z and constants. Okay, given the planes, delta 2 not equal to 0, delta 3, delta 1 not equal to 0, delta 2 not equal to 0, delta 3 is also same manner. Without the constants, write the coefficients of x, y, z. So we are getting the values of delta 1, delta 2, delta 3. Delta 1 is without coefficients of x, without coefficient of y, that is delta 2, without coefficients of z, that is delta 3. We are getting the delta 1, delta 2, delta 3 is not equal to 0, but delta equal to 0. So the sets of the given planes form a prism. So again, common determinant is 0, but 3 or non-zero is there. So given planes form a prism. Second one, to find the delta. Second problem is just you have to see given the nature of intersection. 2x plus 3y minus z minus 2 equal to 0, 3x plus. So x, y, z, just you have to observe the x, y, z coefficients. 2, 3 minus 1, 3, 3, 1, 1 minus 1, 2 is there. So just you have to see the and write the problem. Okay. So find the delta. When the delta is non-zero, directly, therefore, the set of points, planes intersect in a point. When the delta is non-zero, common delta part is non-zero, we are getting the set of planes intersects a point. So that is the second problem. In the same manner, third problem, to find the delta equal to write the coefficients 5, 3, 7. Just you have to see and observe given these equations. Okay, these three are different. Okay, third problem. To write the coefficients of x, y, z in the formation of delta. Okay, to find the delta, delta 1, delta 2, delta 3. Each and every one is 0. So when the delta is 0, delta 1, delta 2, delta 3, then automatically it vanishes because those determinants are 0. The set of the given planes intersects in a line. Okay, no, so that is the simple problem. Don't deviate. Now this is the very important concept. Okay, that's enough. 5.5.2. This is also one of the practice problem, very important in the examination. Okay, nature of intersection is one of the problem is given, and shortest distance problem is also given. Point of intersection. So first 5 units very important in the final examination. Okay, 5.5.2 is also very important. This is not necessary here because this is the lengthy property, lengthy part. Okay. Now at the same time, 5.5.4, these 3 planes are just you have to observe. This is the triangular prism. Okay. First, second, third equations. Prism is also figure is here. Okay. First plane, second plane, third plane. These 3 planes are involved here. First plane is just you have to see here, and second plane, third plane. Okay. To write the ABC values from the coefficients of 1 minus 1, 2. So A minus B plus 2 is equal to 0. From the XYZ coefficients, A plus C equal to 0 from the third equation. To find the values of ABC, so 1 minus 1, 1 minus 1 is here. Now, suppose X equal to 0 in second and third equation, we are getting the values y and z. Y is also 0, z equal to 2. So coordinates of the point, coordinates 0, 0, 2 is there. Okay, those coordinates, according to that, common line of second and third equation is parallel to the plane, first plane. So that is 2 into 1 plus 1 into minus 1 from the normals. Okay, equal to 0. So point is not a on the given the plane. So the given planes form a triangular prism. And again, first equation, first, second and fourth equation, solving the equations 1, 3, 4 is also can be solved. Hello? Capital R has the coordinates 1 by 2, 2 by 2, 5 by 3. So find the length QR equal to square root of 2 by 9 is here. Okay. And perpendicular from point to plane. There are 2 planes is here, mod d1 minus d2 by root of a square b square c square. So we are getting the value is 1 by root 6. And the area of the triangle is 1 by 2 into to root 2 by 9 mean into 1 by root 6. We are getting the value is 1 by 6 root 3. So this is also one of the important problem. Students, the first 5 units when you have to thoroughly practice, then automatically we are getting the good marks. Okay. Last 2 minutes and some other some other important problems in the sphere. See, and the 6th unit is here. Okay, 6th unit. First two blocks are successfully completed. So 50% portion are then easily successfully completed here. So when the thoroughly practiced from the first 6 units, we are easily to get and getting the good marks in the final examination. Okay. Now these problems are also practiced in the final examination. That is the 6th unit is just you have to see and refer. Change of axis. Change of axis. That is not necessary here. Change of axis not necessary. Now just you have to see the first 2 blocks, then automatically to easily to achieve in the getting the good marks in the final examination. And remaining the concept is spheres. Students, listen carefully. Okay. Remaining the concept is spheres, cones, cylinder, paraboloid, and ellipsoid. Okay. Now, due to lack of time, because this is the last session, so that's why we are unable to respond remaining blocks. Anyhow, if you have any doubt, contact us and personally through WhatsApp for the subject point of view. Once again, my number is given 9989476833. This is my number. Now, if you have any doubt, please contact us and personally for the subject point of view. Thank you one and all. Wish you all the best and wish you good luck. Okay. Please stay on the line. Please stay on the line. Okay. Once again, thank you one and all. Wish you all the best and wish you good luck. Students, listen carefully. From the spheres, limiting points problem is one of the important, and the tangent plane problem is also important. Okay. Now those find the center and the radius of the sphere, and the great circle problems are also important in the sphere part. Okay. First of all, that is a simple problem. Find the center and the radius of the sphere. First of all, you must know the what is the equation of a sphere. X square plus y square plus z square plus 2ux plus 2vy 2wz plus d equal to 0. That is the general equation of a sphere. And the center is minus u minus v minus w. And the radius is the square root of u square plus v square plus w square minus d. That is the radius of the sphere. Those problems are also practiced. And especially in the sphere, coaxial system and tangent plane equation. And at the same time, please plane of contact or point of contact problem, and find the limiting points problem especially. Now that is the very easily concept in the sphere part. When you must know the sphere, then automatically easily to achieve the achieve and refer the remaining remaining units, cone, paraboloid, and ellipsoid, ellipses. Okay, that's enough. Okay. Now, once again, wish you all the best and wish you good luck. Thank you. Thank you one and all once again.